Good morning, sixth graders. I'm going to start the classwork for lesson 5 on percentages. Percentages are a comparison of two quantities, just like what we've been doing since the beginning of the year. But this time, we're dealing with quantities where the whole is 100%. So we're going to solve the first problem. It says, on the first math test, Kiko answered 19 out of 25 answers correctly, or questions correctly. On the second test, she got 17 out of 20 correct. On which test did she get a better grade? So when we're solving for percent, there's a strategy. You take the part and you divide it by the whole. But this workbook is walking us through it. So the first question says, write a ratio in fraction form to compare the number of correct to the total questions for each test. So the first test was 19 out of 25, and the second test was 17 out of 20. Can you compare the two ratios as they are written? Explain why or why not. No, because they don't have the same size pieces. Remember, it's hard to compare fractions until they have the same size pieces. Then once they have the same size pieces, you can easily compare. Look at the table. How are 50, 75, 100 related to 25? If you notice, they are skip counting by 25. These are the multiples of 25. If you add a quarter, 50 cents, 75 cents, a dollar. So skip counting by 25. Or in parentheses, I want you to put multiples. What do you need to complete the table? Skip count by 19 on the top. And then it says to complete the table. So 19 plus 19 equals 38. And then 57, and then 76. How are 40, 60, 80, and 100 related to 20? Skip counting by 20 or multiples. Look at the two tables. Which ratio can you use to compare the test results? Why? Okay, so now it's asking us to skip count by 17. So I'm going to go on my calculator. I'm going to put 17 plus 17. And then I can keep hitting the equal sign to fill in the missing quantities. Look at the tables. Which ratios can you compare? You see that we have the same size pieces when you bring it to 100. So you can easily compare 76 over 100 to 85 over 100 to see which one she scored better on. Percentages are good because they bring both quantities to the total of 100%. So why? Because they have the same size pieces. Sorry. Same pieces. Sorry, this is kind of messy. On which test did Kiko get a better grade? Explain. She got a better grade on the second test. More per 100. Remember, you can pause these videos if you ever need to catch up. Okay, the ratios on the previous page, 76 to 100 and 85 to 100, can be expressed as fractions, decimals, and percent. A percent is a rate for every 100 or per 100. The symbol signifies percent. Base 10 models can be used to represent fractions, decimals, and percent. So it's trying to show you that you can go in between both or all three different types of ratios. You can turn your percent into a fraction and then your fraction into a decimal. Okay, this is a base 100 block and they just shaded in 76 to show you that it can go into all three forms. 85% is 0.85, which is 85 over 100. Percentages are per 100. Then it shows you some common fractions that you deal with on a regular basis when we're talking about percentages. You will usually see it in increments like this. So you should be able to go back and forth from fraction to decimal to percent. Sometimes it's easier to use an equivalent fraction when given a decimal or percent. Example, what is 0.25 times 80? Think what is 1/4 of 80? 80 divided by 4 equals 20. So there's some tricks with common percentages. Like 25%, there's 4 quarters in a dollar. You would divide by 4. Or 50%, is half, so you would divide by 2, and things like that. They just show you little tips. Why do you think percents are used to compare ratios when the wholes are different? It brings the ratio to per 100 to compare. Easier. Okay, so this is the first lesson, finding percent. The next lesson we will be doing the percent of a number, finding the part, and then the last lesson is finding the whole. There is a different strategy for each of these different things you're finding in the percentage problem. Remember, when you're finding the percent, you're taking the part, dividing it by the whole. You will get a decimal. You times that by 100, and it will turn it back into a percent.